What's up everybody, my name's Fluffy and welcome back to the Game Zone Universe Sandbox 2 again. And in the previous video we kind of did an overall exploration, I guess is the word, of the solar system and all the planets, and I kind of went a bit into some facts that I know of our solar system. And then we did a couple of collisions. We did Sedna into Mars, and then we did the Moon into Earth, and we did the galaxy collision of the Milky Way and Andromeda. So today I thought what we could do is mess around with stars, because we have yet to see a supernova, and to get a grasp of different sized stars. So once again, bear with me because I'm still trying to navigate around this this game. But there's our sun. So what we're going to do is we're going to just start with our sun, obviously, in the centre of the solar system. And you're probably thinking, well, what can I do to the sun? Well, the first thing I want to do is I want to see... It's got a weird tail coming off it. That's weird. What I'm going to do... there we go. What I'm going to do is I'm going to mess around with the mass, the densities and all that, and see how that affects our solar system. So what I'll do... So the mass is currently 1 sun. What happens if I up it to 5? Whoa, there we go. So it's changed into a sun-nova remnant? What? But as you can see, all the planets, whoa, are now, let's slow everything down. All the planets are going really weirdly, because the sun is now bigger. Its mass is bigger, which I think affects its density. I'm not too sure, I didn't look. But the mass is now bigger with the sun, meaning the sun is bigger, meaning it has more of a gravitational pull. Now this is 5 suns. So this is now 5 times bigger than our sun. Doesn't look like it, but it is. So, I don't know why it says a sun-nova remnant, because that would imply that it went supernova, but it didn't. But let's look at Venus. Ugh, Venus. Oh, Venus is cooking. Look at the surface temperature. Over 1,000, roughly 1,700 degrees on that planet. Because, look, it's now a lot closer to the sun. And because what I talked about with the greenhouse gas effects, that's what I love about this game. The physics of the game are realistic. It's just building up heat. Effectively now it's just a fireball. But look how close it is to the sun. Now, where's Mercury? Did Mercury get shot at? I don't know what that was. See, oddly enough, Mercury is fine. Its surface temperature roughly is still the same as the normal solar system, and its distance is probably maybe a little bit closer, but not too different. Its orbit has changed, so as you can see, its line, it's not a perfect circle. It does this weird little shortcut, I'd say. But that's weird. Venus is coming out here, but I can't see its connecting lines. So either Venus is getting shot out into space, or its orbit is weird. So see, look, it's cooling down. Does it show me its complete orbit? Oh no, it is still maintaining an orbit. However, it's got a weird orbit of going close to the sun and then far away from the sun, which is really interesting. So as it comes around here, the planet will cool down. As you can see, it's gone down to 600 Celsius, which is still burning hot. But as it gets closer to the sun is when it gets into that 2000 degree element. So essentially, if you're living on Venus right now, obviously take the temperature out of the equation of the fact that it's still 500 Celsius. If you were able to survive that temperature, this would be like your winter. It would start getting really, really cold because you're getting further away from the sun. But then as you come round, it would be your summer, but it would be a piping hot summer where the planet is just being bombarded with solar rays and heat, and it essentially turns the planet into a fireball. So right now, you can see Venus has cooled down, but the atmosphere has just been absolutely destroyed. It will stay like that. If not, it might go into an ice. It might ice over as the further it gets away, but judging by how the temperature is slowing down, that's what it's going to remain at. It might cool down a little bit more at that point, because I think that point looks like it's furthest. Yeah, that's its furthest point away from the sun. I don't think it's going to change that often. However, as it gets all the way over to the other side, that's when it will turn into the fireball. Let's look at Earth. Now, Earth's orbit has also changed, so it seems like most of the planets, its orbit has gone from a circle to a oval type shape. Because if you can see, it's doing the same sort of orbit. It's coming around here, which is a distance from the sun, but then it goes really close. See, Earth is 87 degrees, and it still looks the same. I don't think it's had any damage from the sun. What about... I'd imagine all the other planets are the same. Well, I imagine all the other planets are the same, because they all... Really, the first three would be the most affected. So let's, again, up the mass. And then let's keep an eye on the density and see if the density changes. So that's now 5 suns. How about if we take it to 10 suns? So now that is now 10 suns. But the density didn't change. Interesting. Okay. So this is what would happen if the sun were to disappear. Nothing has any... There's nothing in the middle to hold everyone together to create the orbits. So everything's now just floating off in its directions. There goes Mercury. And there's Earth. So look at that. Earth is minus 28 because there's no sun. Let's slow it down. See, look at how Earth looks. It's essentially an ice age. The whole planet is freezing over. I like how it still shows lights for the continents. I suppose effectively no one would be dead. A lot of people would have died from the cold, but minus 34, some survivors maybe. But as it continues, the planet will just keep cooling down, because it's the coldness of space that is affecting it. But yeah, because there's no sun, everything just flies off in its own direction. Vsauce, solar system with a black hole instead of sun. I like how it says Vsauce. Hey, Vsauce, Michael here. Let's actually do that. What would happen if we had a black hole instead of a sun? Simulation shows that the gravitational force between the objects is solely dependent on the masses. Even if our sun was shrunk to the radius of 3 kilometers, creating an extremely dense black hole, the orbits of the planets would be unchanged. That's interesting. So it's showing that with a black hole, because there it is. Whoa. There's the black hole in the center of our solar system, but it's saying that there would be no change. That's weird. Now, can you see how the light forms around the black hole? That's called gravitational lensing. I was going to do another video on black holes, but black holes are related to stars, so do you know what? I'll put it in this video. It's called, but as I was saying, it's called gravitational lensing. I don't know fully how it works, but it's basically an object far away will create a halo around something so you can see it. For example, if I'm correct, if there was a planet behind that black hole right now, and you're looking at it, you'd see the planet bend. It would be a halo around that black hole, because that's what gravitational lensing is. The gravity is so dense, and and light and everything, it just sucks everything up. But that is interesting to know. However, there is no heat being produced. So as you can see, -13 is the Earth. Even Venus is cooling all the way down. There's no light. The planet is just cooling down because there's no sun to produce heat. Black holes don't produce heat, so it's just gonna freeze again. So as many of you might think it might be cool, now you found out that a black hole could be in the center of our solar system and we'd be perfectly fine. No, because we'd freeze to death because there's no heat being produced unless you've saved up on a lot of, you know, logwood fires. I'm not sure what it's gonna take for it. No, it wants sun for it to go supernova. Let's try 100. I'm gonna zoom all the way out for this. There we go. Did work. So that's a supernova. Our solar system is now destroyed. Because we're all inside there. So everything is now dead. Can I? So for example, so there you go, just for example, clicking on Uranus, which is just burning up. Uranus is over 12,000 Celsius. But look, it would just, no, that was Neptune, sorry. It would just keep expanding. And look at the light being produced. Now, a thing about a supernova is that, for example, what I'm trying to say, you can look up at the night sky. Tonight, look up at the night sky and look at the stars. There could be a star that you're looking at that's gone supernova. But it still looks like a star to you. And you're probably wondering why if you don't know. It's all about how long it takes light to travel. So a star could go supernova 100 years ago, because the star could be 100 light years away. It could have gone supernova 100 years ago, but to us it still looks like a star. And then 100 years in the future, we'll suddenly see this bright light in the sky, and this would light up the night sky. It would look like daytime. You'd suddenly see this bright light and what looks like a huge explosion. That's the supernova. But it happened 100 years ago. But light has only just reached our planet. For example, the sun. It takes 8 minutes for light to pass from the surface of the sun to us. So if the sun went supernova, we would not see it essentially, everything you look in space, you can think of it as you're looking back in time. Because that's how long it takes light to travel from whichever object you're staring at. So it's really, really interesting. Just look at it. Look how big it's got. If you think there's our entire solar system there, and this thing is now massive. That is a supernova. And I love supernovas. One of my favourite things about space are supernovas and black holes. It will just keep expanding, but look how massive it is. Still not the size of the Milky Way, but it engulfed our solar system. If our sun went supernova, we'd be dead. Because it would just swallow up the solar system. Our sun isn't due to go supernova anytime soon, so don't worry. But let's start messing around with other suns. So here we go, we've just got an empty simulation. There's nothing here. And we're going to compare suns. Bink. So there's our sun. That's the sun that we know. I don't know what Wolf 359 is, but we'll have a little look. I mean, so look at that. Look how small that is. I thought our sun was one of the smallest suns. But it's not. So let's put in Proximus Centauri. Okay, smaller. But let's put in... See, look at that. It's going to be bright. Yeah, she a bright girl. That is Sirius. Woo! That'd be bright. Let's get rid of that one. And it's still so bright. Sirius is a white star or blue star, and it's bigger than our sun, which is fascinating. Let's get rid of that because that's really bright. Regal? That's another, that's a blue-white supergiant. Whoa! Now look at that! That is terrifying. To know that there's an object that big in space. I'm not done yet, but... There's our sun. There's our sun. Whoa. Compared to Regal. Or Rigel. I'll call it Regal. Wow. That's awesome. I'd love it if we had a blue-white star. They're just so more mesmerizing than the normal stars. But let's go to another star. Oh, Jesus. So look at that. Look at Regal, looks tiny. Compared to Betelgeuse, or whatever you want to call it. It's just hard to look at because of the light off them. I don't know if I can change that. Then you've got, let's go to this one, UY Scooty. Boom. Now look at that. Look at how big that one is. That's massive compared to that one. So that's now the biggest sun compared to ours. Big star, sorry. However, biggest. That, if I'm correct, goes to this fella here. But we got some more. What we got down here? Mirachi. Not that big. Crab pulsar. Tiny. So these are just pulsar stars. No problem. Let's go to this guy. VY Canis Majoris. This is a red luminous super giant. And it is the biggest star that we've ever discovered. I believe. Should be. Oh. Wait. What? It's smaller than that. No way. We found one bigger? Last time I knew that VY Canis Majoris was the biggest star that we found. But that looks bigger. Okay. Even I'm learning stuff. And I fucked the game up. It stopped recording. Woohoo! It has stopped recording. It stopped playing. I think I chose something that was too much for the game to handle. I'm gonna leave the video here because I can't do anything else. So, thank you everybody for watching. I hope you've enjoyed watching it as I've enjoyed playing it. My name is Fluffy. This has been the Game Zone. Bye bye!